Okay, so in this video we're going to have a look at some of the hardest Surds exam style questions. Now they're in no particular order, but we're going to have a look at 5 questions that are all pretty tricky in their own way, and we're going to kickstart with this question. So grab a piece of paper, grab a pen, make some notes, and don't forget to check out all of the other Surds videos that I've got linked in the description below, where I've run through Surds right from start to finish. So this is really, the final part in that series. So do make sure you've checked out some of those first, because I'm going to assume a lot of knowledge already from those videos towards these questions here. So some of the bits I may go a little bit fast if you're not already quite clued up on Surds. So here we go. This question here, it says, show that this surd here, this big horrible fraction thing, can be written in the form a brackets b plus root 2, where a and b are integers. So just having a look at this question and how we're going to approach it. First of all, we've got to expand that bracket on the top of the fraction there. Okay, and then we can have a look at rationalising it. But before we've expanded that, we're going to struggle to rationalise it. So let's go about doing that first. And again, I'm going to do it in my own way here because I am going to expand that bracket as it is. I'm not going to think about simplifying that root 18 first. And I'll show you why as I go about doing that. So for starters, let's expand this top part. So we have root 18 plus root 2, and that's getting multiplied by another root 18 plus root 2. There we go. Right, and you'll see now why I don't simplify the root 18. So when we expand this then, let's see what we get. So root 18 times root 18 is 18. Root 18 times root 2 is root 36. I'm just going to write that here because the square root of 36 is the whole number 6. So that's just going to be plus 6. Underneath, we've got the same sum there again. Root 2 times root 18 is going to be root 36 again. So that's another 6. And then root 2 times root 2 becomes 2. So there we go, that's why I didn't simplify it, because they straight away all turn into nice whole numbers for us. So there we go, we've got our numerator sorted. So our numerator, if we add those all together, they all equal 32. So that's 32 on the top, and on the bottom, we've got root 8 minus 2. Now what I am going to do is I think I will simplify the root 8 at this point. Obviously when we rationalise this now, we're going to times both sides by root 8 plus 2. But instead of doing that, I'm just going to simplify this root 8 to start with. So let's go for that. That becomes, let's see, what's that going to be? It's root 4 times root 2, so it's 2 root 2. There we go. Obviously, if I am going quite quick on some of these, you do need to obviously go back into those playlists and check out some of these videos on simplifying surds and things like that. Right, so let's get rid of that then, and let's turn that into 2 root 2. There we are. So 2 root 2. And now we can times the bottom by 2 root 2 plus 2. Right, so let's write that as a bracket. So 2 root 2 plus 2. And we'll do the same to the top as well. So times that by 2 root 2 plus 2. There we go. So I'm going to imagine the bottom part here is in a bracket as well, just so that I can do my double bracket on the bottom there. So expanding this, on the top we've got 32 times 2 root 2, and that's going to become, and let's write this over here, 32 times 2 is 64, so 64 root 2, plus, and then 32 times the 2, 64. And that's all going to be over. And again, don't forget your little tricks when you're rationalising on the bottom here. I only have to times the first and the last. So 2 root 2 times 2 root 2 becomes 4 root 4. I'm going to write that down, 4 root 4. Root 4 is 2, so it's 4 times 2. So that becomes 8. There we go, so we get 8 there. And then the last ones, we've got plus 2 times minus 2, which is minus 4. Right, we're almost done. Now we can simplify the bottom there. So that's going to become, let's have a look, 64 root 2 plus 64 on the top, and that's all over 8 take away 4, which is 4. Right, so now we can actually simplify this, because both those numbers on the top there divide by 4. We've got the 64 and the 64, they both divide by 4. So if we go about doing that, 64 divided by 4 is 16, so we get 16 root 2 plus 16. There we are, and then we can finish this off. Look, it wants it in that form at the top, a brackets b plus root 2. So here we go, if we factorise 16 out, we get 16 lots of root 2 plus 1. And obviously the final answer, it wants the b at the start, so we just need to swap these round now. So that'll be 16 brackets 1 plus root 2. And there we go, and there is our final answer for that particular question. Let's highlight that. There we go. So there's our final answer for this first question. So as you can see, pretty tricky. We had to expand a double bracket on the top. Then we had to obviously go about rationalising it. Then we had to simplify it, factorise it, and give it in the format that they actually wanted in the question. So our value of A there is 16, and our value of B is 1, and we have that root 2 there that they're asking for. Right, so there's our first question. Let's have a look at our next one. Okay, so on to our second question. I actually think this one's quite tricky, and I'm going to show you why at the end, and there's a bit of a hint here in the words that it's going to be tricky. It says show that can be written in the form a plus b root 2, and it says find the values of a and the value of b. Now normally in that language there it would say where a and b are integers, but it doesn't, and that gives us a little bit of a hint here that a and b are not going to be whole numbers. So that gives us a little bit of a clue towards the end that this isn't going to be very nice. So let's go about this question. It's very similar to the last one in the sense that, look, we have this double bracket on the bottom that we need to expand first. So I'm going to go about expanding that. So we've got 3 minus root 2 and another 3 minus root 2. There we go, we need to expand that. Okay, so let's expand that. 3 times 3 is 9. 3 times the negative root 2 is negative 3 root 2. Onto the bottom, negative root 2 times 3 is another negative 3 root 2. And then negative root 2 times negative root 2 gives us plus 2 at the end. There we are, and if we simplify that, let's see what we get. We get 9 add the 2, which is 11, and then those two negative 3 root 2s will become negative 6 root 2 when we combine those together. Right, there we go. So that is our new denominator. So let's write this actually out with our new denominator. So we've got 1 plus root 2 on the top, and on the bottom we've got 11 minus 6 root 2. There we go. Right, so now we've got something we can actually rationalise. So we need to times the top and bottom by 11 plus 6 root 2. So let's put these into brackets because we've got a double bracket on the top and the bottom for this one. So we're going to times the top by 11 plus 6 root 2. And on the bottom there we've also got 11 plus 6 root 2. Right, and let's expand this then. Okay, so 1 times 11 on the top gives us 11, so let's just write this. So from my numerator I've got 11. 1 times the 6 root 2 is 6 root 2, so plus 6 root 2. On the bottom, root 2 times 11 is plus 11 root 2, and then root 2 times 6 root 2, let's extend that a little bit, it's going to give us positive, and we've got 6 lots of root 4, 6 root 4, I'm going to write this over here actually, 6 root 4, which is 6 times 2, so that gives us 12. There we go, so plus 12 at the end. Right, there's our numerator. We'll look at simplifying that in a second and obviously just collecting the pieces together. Let's have a look at the bottom. So 11 times 11 is 121, and negative 6 root 2 times positive 6 root 2 gives me negative 6 times 6 is 36, root 2 times root 2, that's not 36, that's a 3. There we go, 36. Root 2 times root 2 is root 4. So that's 36 times 2, which is 72. There we go, so it's 121, take away 72 on the bottom. Right, okay, so now we can move on to our next step, which is simplifying it all down. So we've got the 11 add the 12 on the top, which is 23. The plus 6 root 2 and the plus 11 root 2, that's going to make plus 17 root 2. There we go. And on the bottom we have 121, take away 72, and that is 119, take away 70, 49. There we go, so 49 on the bottom. Okay, so we're almost there. Kind of at this point here, we're thinking, well, how are we ever going to make this look like what it's asking for? How are we going to make this, say, a plus b root 2? So there's a little trick here that we can approach. We can just chop this fraction into 2 fractions, so I can kind of almost split it down the middle. So that 23 is being divided by 49, and that 17 next to the root 2 is also being divided by 49. So I can rewrite this as 23 over 49, add the 17 over 49 along with the root 2. And you could put that root 2 on the top there with the 17. It could be 17 root 2 all over 49, but the question wants it written in this particular way, so I'm going to write it in that way there. So the value of a is 23 over 49, that horrible fraction, and the value of b is 17 over 49, and there's our 2 pieces that we need to answer this question. There we go, and there's the end of that question there. Pretty horrible. I think actually that last step there is probably the nastiest part about this. Just the fact that when you would get to that point at the end of an exam question, you'd probably be looking at that and thinking, this can't be right, something must have gone wrong here. You usually expect whole numbers, but there you go, that just goes to show you just to look out for that little trick in the words there. If it doesn't say they're going to be whole numbers, obviously we shouldn't be expecting them to be whole numbers. But there we go, there is our second question. Let's have a look at our next one. Okay, so for this next question, this actually looks like one of the worst questions out of the bunch here actually, but it's actually not that bad at all. Now there's a couple of different ways that you could approach this. I'm going to apply one little method and just see what we get for it. So we've got 1 over 1 plus 1 over root 2 to start with. There we go. Now what you could do, and this is not the method that I'm going to do, but what you could do is you could actually just go about rationalising this little fraction on the bottom to start with. Okay, so you could do that. That's one method, although it is a little bit longer than the method I'm going to use, so I'm not going to apply that approach. But you could actually go about just rationalising that to start with and seeing what you get. But the approach that I'm going to take is slightly different. Now, you might be looking at this and thinking, okay, well, when it's 1 plus something with a root on the bottom, we'll flip the sign, we'll do 1 minus 1 over root 2 and times it by that. But again, that's going to overcomplicate things as well. So there's a nice little approach that we can take here, which is just down to the way we rationalise little basic surds, and that is just to times the top and bottom by whatever root is on there. So the root is a root 2. So if I times the top and bottom by root 2, let's see what we get. So times root 2. Times root 2, and we get root 2 on the top. 1 times root 2 is root 2, and on the bottom we're going to times the 1 by the root 2. Let's have a look. So times that by the root 2, we get root 2, and we'll times this second piece here by the root 2. And remember, when you times a fraction by anything, by a whole, like a single piece like that, it's just going to multiply the numerator there. So that becomes root 2 over root 2. There we go. Now root 2 divided by root 2, anything divided by itself is 1. So actually that root 2 over root 2 is just the number 1. So what we've got is root 2 over root 2 plus 1. There we go. And now we're in a position where it actually doesn't look too bad to rationalise. In fact, that's a relatively simple one to actually rationalise now. It's just that it was actually getting there in the first place. So now we're at that point, and I might discuss the other ways that we could approach this as well at the end. I'll see how we go with this one. But now we can just times the top and bottom by root 2 minus 1. So times by root 2 minus 1, and times by root 2 minus 1. There we go. So on the top, let's see what we get. Root 2 times root 2 is 2. I'll write this here, so 2. And then root 2 times the minus 1 is minus root 2, so 2 minus root 2. And at this point, look, we'll be quite happy because it's matching that there. And on the bottom, let's see what we get. So the root 2 times the root 2 is 2, and the 1 times the negative 1 is minus 1. There we go. So that's all going to be over 1 now. 2 take away 1 is 1, so we get 2 minus root 2 all over 1, and anything divided by 1 we can just get rid of that denominator there, so it's 2 minus root 2, and that matches what it wants in the question there. So there we go, there's our final answer for this Surds question. Now just thinking about another way that you could have looked at this, if you did rationalise that one over here to start with, if we imagine times in just the top and bottom of that by root 2, what would we get? We would get root 2 over 2. And then again, how would we approach this now? We'd have to now combine that with the 1, and then we would have to, and then we'd have to do 1 divided by that. In fact, that is definitely going to overcomplicate things. So actually looking at that there, if you did rationalise that, you'd end up having quite a complicated little bit of surds that you'd have to do here. You'd have to make the 1, 2 over 2. You'd have to add them together. So you would get 2 plus root 2 over 2. This is definitely going to overcomplicate it a little bit. And then that's all being divided by 1. So you'd have to do 1 divided by that. Again, you can probably see why I didn't want to go down this route, but we've got 1 over that, or in other words, you could write 1 divided by that. So 1 divided by 2 plus root 2 over 2. Again, you don't need to worry about this method that I'm doing now. I just want to show you there are other ways of approaching it. Just some are more complicated than others. And obviously when we're dividing fractions, we have to flip the second one over. So actually that's going to be 1 times 2 over 2 plus root 2. And that eventually now gets us, look, to that 2 plus 2 over root 2, 2 plus 2 root 2, and then we'd have to actually go about still rationalising that. So it's not the nicest there. We'd have to still rationalise that. What would we have to times it by? 2 minus root 2. And then we'd have to sort of simplify it all from there. It starts to really sort of overcomplicate things. But that is another way that you could approach this question. So just showing you there are multiple ways of solving some of these problems. I'm not going to go through the whole question there, but just another way that you could approach it. But actually I think the way that I showed you in the first place is a lot easier than that. That's why we'll probably just stick with that method. Let's just get rid of that. There we go. So there's our final answer, 2 minus root 2. And obviously just thinking about applying the easiest method you can right from the start if it's possible. Right, let's have a look at our next question then. Okay, so this question has our first introduction of letters into the surds here. We've got a plus root 8 squared can be written in the form c plus d root 2, where a, c and d are all integers. Find in terms of a an expression for c and d. So in other words, we're just trying to find what piece goes here, what piece goes here. Again, we're going to write that as an expression. Remember, an expression is just a piece of algebra that doesn't have any equal signs in or anything like that. So we're going to have a look and see how this goes. So let's go about expanding that. So we've got a plus root 8 and another a plus root 8. Now I guess you've got to ask yourself at this point, do we bother simplifying that surd, or do we just go for it and simplify it at a later point? So I'm just going to go for it. I'm just going to, just it doesn't really matter when we simplify it. So I'm just going to go expanding it, and I'll just to simplify it sort of as we get through a little bit more. So we've got a times a to start with, which is a squared. Then we've got a times the root 8, so that's plus a root 8, a lots of root 8. Same again for underneath there, we've got another a lots of root 8. And then root 8 times root 8 becomes 8, so plus 8. Alright, there we go. That's why I quite like not simplifying it at the start, because I know that it's going to create that whole number there for me at the end, and then I have less simplifying to do. So joining these two together, we've got 2a root 8 there. We've got two of those a's in front, so we just add together the a's, that's 2a. So we have a squared plus 2a root 8 plus 8. Now we definitely need to think about simplifying that root 8 now, because we're kind of at a point where we can't add any of these pieces together. So root 8 is 2 times 4, so it's root 4 times root 2, or 2 root 4, or 2 root 2. There we go, root 8 is 2 root 2. So let's just write that out. So we've got 2a, lots of 2 root 2 in the middle, and 2a times 2 would be 4a, so we're going to have 4a root 2. Right, so let's rewrite that. So we have a squared plus 4a root 2 plus 8. Now we can't simplify this any further. It is at our final piece there. We just need to figure out how we're going to write it like they want it above. Now the only thing that's stopping us from actually having an answer that looks like the one above is this plus 8 at the end. So all we're going to do is we're going to move that that plus 8, and we're going to stick it over here by the a squared. So we have a squared plus the 8 plus 4a root 2. So all I'm doing is writing it in a different order right now. And there we go, that is our final piece there. Now if we have a look, in terms of the bit at the start, before the root, the c part from up here, how they wanted it, is this entire piece here. So c is equal to a squared plus 8. That's our expression there, a squared plus 8. And d, the piece in front of the root 2, is 4a. There we go, and there are our two pieces, a squared plus 8 and 4a. Not the nicest there, just because it doesn't look very nice again. It's just sort of one of those questions that you'd probably start getting through, and you'd be looking at and you'd be thinking, hold on, this definitely shouldn't be how it looks, something's gone wrong, but actually just sort of believing in yourself and just going for the process and trusting in your knowledge of surds here. But there you go, that is question 4. We're going to have a look at our last question here before we finish. Okay, so for our last question, we've got some slightly different maths going on here. We've got some surds involved in a geometric sequence. So a geometric sequence, just in case you're unsure of this one, is just something that's being multiplied each time to get the next one. So let's imagine we start with a nice easy one. So we've got 2, and let's just imagine it's being times by 3 each time. So 2 times 3 would give us 6. We times it by 3 again. There you go, and it would give us 18, and that is forming a geometric sequence. So what we've got here, we've got the first 3 terms of a geometric sequence in terms of surds. So it says we've got root x minus 1, 1, and then root x plus 1. And it says it wants us to find the value of x. Now remember, when it says find the value of x, that is asking us to solve an equation, okay? It's asking us to solve to find the value of x, which means we're going to have to create an equation here. We're going to have to think about how we can actually create an equation. Now, if I look back at my geometric sequence that I drew up here, there's a little equation that I could make from this, even though it's just simple numbers. There we go, and we've got no algebra there, so it's not really going to create an equation, but I can write an equal sign in this. What I can do is I can take the bigger number and divide it by the small number, so 18 divided by 6, and if it's a geometric sequence, that should be the same as or equal to, let's just highlight this in a different colour, this second term divided by this first term, so 6 divided by 2. So let's have a look. 18 divided by 6 is 3, 6 divided by 2 is 3, and that is a correct and true statement there, isn't it? So that's absolutely fine for me to do that. Now that's the logic that I'm going to approach in this question to actually form an equation, because actually the pieces in this one are going to have algebra in. So if I get rid of this, look, I'm going to apply exactly the same logic as I've done above there. I'm going to take the bigger number and divide it by the smaller number and set it equal to the next one divided by the one before it. So the first two I'm going to look at are the first two this time, so we'll say 1 divided by root x minus 1 has to be equal to the following two, and the following two we've got the 1 and the root x plus 1. So the bigger number would be the root x, so root x plus 1, not necessarily the bigger number actually, but the next number in the sequence divided by 1. There we go, and there is our equation. So that's something now we've got to solve. So we've got obviously some sort of algebraic fractions really, involving surds as well. So there's quite a lot of different topics in here. We've got geometric sequences, algebraic fractions, surds, a pretty nasty mix, a pretty nasty combination. So you've got a definite grade 9 question going on here with all this stuff going on in this particular question here. It's a very nasty one. So if we cross multiply, we're going to times the 1 up to the other side, and this denominator up to there. So 1 times 1 is just going to give us 1 on the left, but on the right here we're going to have a double bracket. We've got the root x plus 1, there we are, in one bracket, and we're going to multiply that by the denominator on the other side, which is root x minus 1. Now actually, if you can get yourself to this point, that's the hardest part. The rest of it is not actually too bad, because expanding this bracket's nice and easy, and we get our solution quite quickly now. If you might actually be able to see it if you're quite clued up with these already, but because it's root x plus 1 and root x minus 1, we've got a difference of 2 squares there, so it's just like when we rationalise on the bottom. There's only actually 2 multiplications I have to do, but let's have a look. We've got root x times root x, which gives us x. We've got root x times minus 1 and root x times the plus 1. They're going to cancel each other out, so I'm not going to bother doing them. I can already see it's a difference of 2 squares. And then the plus 1 times the minus 1 just gives me minus 1 there. So we've got 1 is equal to x minus 1. So add 1 to both sides. We get 2 equals x, or x equals 2. There we go. And there's our final answer for the first part. 2 equals x, or x equals 2. Now the second part of this question, it says show that the fifth term of s is 7 plus 5 root 2. So we've got some of the numbers already. Let's have a look. We've got those first 3 terms given to us, but now we know what x is, we can actually turn those into numbers. So for part B here, let's just label that as part A. Part B, let's replace those pieces with numbers. So the first term in the sequence is root 2 minus 1. Again, just replacing this x here. The next number was 1, and the next number was root 2 plus 1. Now going back to my original sequence, obviously when we have a look at this sequence here, if I said what's the common ratio between these, or in other words what's it being multiplied by, you'd probably be able to spot quite quickly that it's being multiplied by 3. Now when it comes to this one, we've got to take a slightly different approach here and think, how are we going to figure out what it's being times by? And we could do the bigger number divided by the little one and use that as our common ratio, but actually if we look, because one of the numbers is 1, it's quite easy for us to spot what it's being multiplied by, because 1 times anything creates that thing whatever you times it by. For example, 1 times 8 is 8, so that must mean if it was 1 and then 8 in a sequence, we would have to be timesing by 8. So looking at this one here, obviously the next number in the sequence after the 1 is root 2 plus 1, so we must be multiplying by root 2 plus 1 each time. So all we need to do is keep multiplying by root 2 plus 1 until we get to our 5th term. So to get our 4th term, there we go, we would have to do the root 2 plus 1 times by another root 2 plus 1, as that's what we're multiplying by. And if we expand that out, let's see what we get. Root 2 times root 2 is 2. Root 2 times the 1 is root 2. Underneath, again, another root 2. And then 1 times 1 is 1. And if we combine that all together, we get 3 plus 2 root 2. There we go, 3 plus 2 lots of root 2. Now, obviously moving on to the 5th term, because that's our 4th, we're looking for the 5th. So for the 5th term, we have to do this thing, 3 plus 2 root 2. There we go, we're going to multiply that again by the common ratio, which is root 2 plus 1. So multiply that by root 2 plus 1. And if we expand that, let's see what we get. I'm running out of a bit of space here, so let's see if I can move some of this out the way a bit. Move that up there. It's just about, let's try and move everything out the way. Right, let's move all of this. There we go. Let's put that up there. Right, okay, so It's taken my root with it. Let's get rid of that. Right, so we're moving our 5th term now. So where's my green one gone? There it is. Right, we're back to business. Right, so timesing these together. Let's see what we've got. We've got 3 times root 2, which is going to give us 3 root 2. We've got 3 times the 1, which is going to give us 3. Root 2 root 2 times the root 2 is going to give us 2 times 2, which is 4. So plus 4. And then the 2 root 2 times the 1 gives us another 2 root 2. There we go. And we just need to simplify all that down. So what have we got? We've got the 3 and the 4. That's going to add to make 7. And we've got 3 root 2 and 2 root 2, and they combine to make 5 root 2. So 7 plus 5 root 2. Quick check. Lovely, that's what it was asking for. There we go, so there's our final answer, and that is how you would approach a question like that, although that is very difficult. Obviously, as I said, that is quite a high-end grade 9 question there, because you had the involvement of surds, you've got algebraic fractions, you've got geometric sequences, and it's all difficult elements of all of those topics as well, so none of that is easy there. But there we go, that's the end of the video. They are the 5 hardest Surds exam style questions in my opinion. Obviously you might have found some slightly harder ones, okay, so obviously if you have, you can always drop those in the comments, so feel free to do so, and I will try and do my best to go over those as well. But that's the end of the video. Hopefully you found that useful. If it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.